All right, this is part 2 of the review for test 2. This says if alpha is in a second quadrant angle such that sine of alpha is 5/11 and beta is a third quadrant angle such that cosine of beta is -4/13, find the following. So we're still doing the addition formula for sine. So we're going to have two pictures here, one for alpha and one for beta. So alpha is in, hang on just a second, words rebooting. Okay, so I'm going to redraw this alpha quadrant. So alpha is in quad 2, and they told us that the sine of alpha is 5/11, so 5/11, opposite over hype. They told us that beta is in the third quadrant, so beta's down here. And it has a cosine of -4/13. So -4 for x, 13 for the hypotenuse. So we need to first find out the missing sides for each of these. So this would be x squared plus 5 squared equals 11 squared. And that would be 25, that would be 121. So if we subtract, that's going to be 96, I believe. I'm sort of still 6. I'm going to double check that. Yeah, 96. So then we take the square root of that. And remember, we're going with the negative case here because this is in the second quadrant for x. Now, I believe that 4 might divide into this. Let me double check. Yep, so 4, oh, actually 16 will divide into this. So this has definitely got a perfect square. So this is -4 on the square root of 6, because this breaks down into 16 times 6. Okay, and then let's do the other one. This would be -4 squared plus y squared equals 13 squared. So that's 16 plus y squared equals 169. Subtract the 16. That's going to be 153. And that's the square root of that. And it's also going to be negative because we're in quad 3 and the y's are negative here. Now I need to double check to see if 153 has any perfect squares. 3, yeah, I believe it does have perfect squares, so we're going to have to rewrite that. That's not the correct side length. Okay, so let's see. 3 goes into it twice because 3 also goes into 51. So it looks like 153 is divisible by 9. Yep. So this breaks into 9 times 17. So this is -3 on the square root of 17 because we have to take the square root of 9. So -3 square root of 17. And this guy right here is -4. Oh, wrong color. -4 square root of 6. Okay. So what we can find from this is, remember, the sine, cosines, and tangents of all these. But since we're doing the sine addition formula, we only need sine and cosine. So we already know sine of alpha is 5/11. We now know that cosine of alpha is -4 square root of 6/11. And then we knew that cosine of beta was -4/13. Now we can get that sine of beta is -3 square root of 17/13. Okay, so we have everything we need to plug into the formula. The formula for sine of alpha plus beta. Remember, sine is social and agreeable. So sines mix with cosines, and we stay with the same symbol. The only thing you want to just make sure of is that you didn't use sine beta twice or cosine alpha twice. You need to have different ones. So sine of alpha is 5/11. Cosine of beta is -4/13. Plus cosine of alpha is -4 square root of 6/11. And sine of beta is -3 square root of 17/13. The first fraction will be -20 over whatever 11 times 13 is. That is 143. And then on this one, we have to be careful. This is negative times negative, outside number times outside number. So that'd be positive 12. And then we need to do 6 times 17 for the inside. So that's 102. You may have to reduce that, just depends on if it reduces or not. I don't believe this one does. So my final answer is negative 20 plus 12 square root of 102 over 143. Now that's the answer for sine of alpha plus beta. We're going to do the same exact angles, and now we're doing cosine of alpha plus beta. The reason for this is we're trying to figure out what quadrant this new addition of alpha and beta is going to actually be located in. So if we do cosine of alpha plus beta, remember we're antisocial and disagreeable, so cosine alpha, cosine beta, minus sine alpha, sine beta. This would be cosine alpha is negative 4 square root of 6 over 11. Cosine of beta is negative 4 over 13. Minus sine of alpha is 5 over 11. Sine of beta is negative 3 square root of 17 over 13. This time we get positive 16 square root of 6 over 143. Negative times negative will be positive, and this is 15 square root of 17 over 143. So a final answer of 16 square root of 6 plus 15 square root of 17 all over 143. Now, how does this tell us what quadrant we're in? You'll have to go to decimals for the first one because you don't really know just staring at that if that's a positive or a negative fraction overall. I know there's a negative out front, but you're adding it to something. So this is 102 square root times 12, and then we're subtracting 20 from that. So notice that's going to come out positive because we're going to divide it by 143. So this comes out positive when I worked it out on my calculator. This one will also come out positive since it's all pluses. So that means that we are in quad 1 because where are sine and cosine both positive? It's in quad 1. So that's how you figure that out. You look at the two answers, figure out decimal-wise whether or not they're positives or negatives, and that'll tell you enough information to find out the quadrant. So that's that one. Okay, for number 18, we're verifying an identity as well. And notice that there is this sine of 2 theta in the top. Remember, that's a double angle formula. And remember, our double angle formulas are sine of 2 theta. Remember, this is found by the addition rule. Is 2 sine theta cosine theta. Cosine of 2 theta is cosine squared theta minus sine squared theta. There are other versions of that, but remember that's the main one. And then tan of 2 theta is 2 tan theta over 1 minus tan squared theta. And all of those are found by the addition formula. So if we use the sine of 2 theta to replace the top here, this would become 2 sine theta cosine theta over sine theta. And then the sine thetas would cancel out, so we'll immediately get that that's 2 cosine theta. And then let's do this one. Cosine of 2 theta. If we replace that on top with the cosine squared, so this is again a double angle formula on top, we can replace that with cosine squared theta minus sine squared theta of cosine theta. And then we can make that 2 separate fractions because it has a monomial in the bottom. That would be just cosine theta for the first one. This would be, I would split this up into sine theta times sine over cosine theta since there's 2 sines on the top. So then that would be cosine theta minus a sine theta, and sine over cosine is a tan theta. And that is the same thing as this, they just have the order different for the multiplication. And then for number 20, we're going to use the replacement for the tan of 2 theta. So again, using my double angle replacement. So this guy right here would actually become 2 tan theta over 1 minus tan squared theta all over tan theta. So I'm going to think of that as tan theta over 1. I'm going to multiply by the reciprocal here. So 2 tan theta over 1 minus tan squared theta times 1 over tan theta. One of the tan thetas cancels with this tan theta, and then we're just left with 2 over 1 minus tan squared theta. So these, as long as you know those double angle formulas, they come out right away, and they're really simple to prove. Okay, let's look at the next group. So we're talking about number 21. It says use the given conditions to find the exact value of the double angles. Okay, so again, we're going to need to draw pictures for a lot of these. So tangent is negative because it's negative 8 over 15. Cosine is positive since it says greater than 0, so we need to locate the correct quadrant to find our sines and cosines. So negative tangent and positive cosine, that would end up being in quad 4. And tangent, remember, is opposite over adjacent. So we still need to find our hypotenuse. So that's 225 plus 64 for the two squares, and square root of 289 is 17. So that means that sine of theta right here is negative 8 over 17, and cosine of theta is 15 over 17. Now this is what we're trying to do. So we're trying to do sine of 2 theta, which we know by our formula for double angle is 2 times sine theta times cosine theta. So 2 times negative 8 over 17 times 15 over 17. That ends up being negative 16 times 17. So that's negative 272 on top. And 17 times 17, I believe, is 289, but we're going to double check that. Yeah, 289. And then we would just have to ask if that's reducible. I don't believe that it is, but I haven't gone through and checked all of it. I can check the answer key real quick. Just make sure so that we know for sure. And yep, it's a good thing I checked because I just realized I multiplied times 16 and 17 on top, and it's actually 16 times 15. So not paying attention and being sick doesn't help. So that's a negative 240 on top. So let me fix that. Super easy to make mistakes when you're not closely paying attention. So there's that fraction. Okay, so let's do 22. This one is sine is positive because it's 7 over 25. Cotangent, remember, is your tangent family. So tangent is also positive because it's greater than 0. So sine and tangent are both positive in quad 1. So sine is 7 over 25, and 25 squared is the hype minus the 49. That's 576, which the square root of that is 24. And everything's positive since we're in quad 1. Cosine of 2 theta, we're going to need cosine squared of theta minus sine squared of theta. So cosine of theta is 24 over 25, and they already gave us sine theta. So this is 24 over 25 squared minus 7 over 25 squared. 24 squared is 576 minus 49 all over 6, not square root, 25 squared, 625. And if we do 576 minus 49, that is 527 over 625. And I don't believe that one reduces either, but I'm going to double check. Yeah, it's good. Okay, for number 23, we were given that secant is 13 over 5, and cosecant is less than 0. So secant, remember, has to do with cosine family. So cosine's positive, and cosecant has to do with the sine family, and it's less than 0, so that's negative. So cosine being positive, but sine being negative, that's in quad 4. Okay, and then we want to label our triangle. Now, they didn't give me cosine, and so you have to be careful here. They actually gave me secant. I'm going to rewrite that as cosine by flipping it. So it's 5 over 13. So this is 5, this is 13, and then this is going to be a negative y, and it's 169 minus 25. So it's the square root of 144, so this is negative 12. So all we need for the tangent formula, remember, is actually tangent. We need to do 2 tan over 1 minus tan squared. So we just need to find tangent from this. So tan theta is opposite over adjacent, so that's negative 12 over 5. So this is 2 times negative 12 over 5 over 1 minus negative 12 over 5 squared. That is negative 24 over 5. And this would be 144 over 25, and then that's minus that. So that's 25 over 25 minus 149 over 25. 25 minus 149 is negative 124 over 25. And then I'm going to have to write this down here into this next problem. Sorry for that. So negative 24 over 5 times 25 over negative 124. That reduces. So does 24 and 124. Yeah, they're both divisible by 4. So this would be a negative 6 and a negative 31. And so this is actually negative over negative altogether. So this is positive 30 over 31. So that one's a little hard to see, but I just reduced it all the way down. So, which is not what they got for it. So let me double check real quick. Okay, I see where my error is. I'm going to back up. It's because I got to a point where I was writing too small. So let me erase this. I did 25 minus 149, and that's actually a 144. So I couldn't read my own writing. So 25 minus 144 is negative 119 over 25. So that's why this isn't going to work out so nicely. So then we would have negative 24 over 5 times 25 over negative 119. So then we do still reduce that. So 24 times 5 is negative 120. So this is negative 120 over 119, negative 119, so they're both going to turn out positive since it's two negatives. So there we go. Now that matches with that one. So 120 over 119. Okay, let's look at number 24. Okay, so for these next three, I went ahead and wrote down the half angle formula, so I took a side minute to do that because I didn't have any room. So this is the formulas we need for, if you're doing a half angle of theta, so half of the original theta, it's going to be plus or minus depending on what quadrant the half angle is supposed to be in, and we'll figure that out by showing you a trick on that. And then it's just square root of 1 minus the cosine of the original angle divided by 2. Cosine half angle is also plus or minus depending on the half angle's location, and then square root of 1 plus cosine theta divided by 2. And tangent half angle is plus or minus, and then we have the square root of the sine over the cosine, so the 2's cancel out. So you just get 1 minus cosine over 1 plus cosine, and that's all under a square root. So let's go back up and look at number 24. This tells us that sine of theta, the original theta, is negative 12 over 13, and tangent of theta is negative because it's less than 0. So tan is negative, and sine is negative as well. So that means that theta's location, which is going to help us with the actual formula, but we'll still need to locate the half angle to figure out where we're going to do our sine for the beginning of the formula. So theta's location has to do with where is sine and tangent both negative. So that means that we are looking at quad 4, I believe. Yes. So then this labeling would be negative 12, and this would be 13. And if we use our quadratic formula, I believe we get that this, or not quadratic, Pythagorean identity, sorry, this would be negative 5. Not negative 5, sorry, positive 5. So we have positive 5, negative 12, and 13. I'm obviously getting tired. So what we're talking about now is we're doing a cosine half angle. Now to do either the tangent sine or cosine half angle formulas, we need cosine from this picture. So cosine of theta is 5 over 13. That's the only reason we needed to draw this picture, was to figure out what cosine of theta is, because all of the half angle formulas use cosine. Now, what we need to talk about, though, is that the location of this angle dictates where the half angle is going to be located. So the half angle's location, Since we were in this quadrant, this was 270 degrees to 360. Somehow degrees are always easier for people to understand. So 270 to theta to 360. We cut all of this in half to figure out the half angle's location. The reason we need that location is to know if we're going to pick plus or minus in front of our formula. Okay, that's why we care. So half of 270 would be 135. That'd be theta over 2. Half of 360 is 180. So it looks like this is in quad 2. And cosine in quad 2 is negative. Okay? So cosine specifically, if it was tangent, we would think about where is tangent in quad 2. So because of that, we're going to choose the negative form of that formula. So cosine of theta over 2 is going to be negative square root of 1 plus cosine theta all over 2. So this is negative square root of 1 plus the 5 over 13 all over 2. And you can multiply everything on top and bottom by 13 to clear out that fraction. That would be 13 plus 5, because 13 times 1 is 13. 5/13 times 13 is just 5. And then this would still be over a square root now of 26, because we'd be multiplying by that. And I'm not sure if they're making us rationalize these. Let me look really quick. Yeah, it looks like we eventually will. So let's add the top first. So this is negative square root of 18 over square root of 26. To rationalize that, I actually think it would be easier to pull a square root of 2 out of both top and bottom. You don't always have to make things bigger. You can sometimes break them apart. And the reason I want to do that is because then the square root of 2's can cancel out. So now the square root of 9 is 3, and then I have a square root of 13 in the bottom. So I need to rationalize by multiplying by square root of 13 on top and bottom. So this one's negative 3 square root of 13 over 13. So that's the answer for number 24. I will obviously need to probably give myself more room to do 25. So give me just a second and I will delete 26 and put it on the next page. Okay, I moved 26 down to the next page so that I'll have more room to do 25. Okay, so for 25, we were given that cosine is a negative angle. So if we're looking for theta's location again, and sine is also negative here because it's cosecant. So where is cosine and sine both negative? That is down here in quad 3, so that's where theta is located. So then this would be negative 15, and this is 17, and that is 289 minus 225, and that's going to be, the other side is going to be a negative 8 because of where we're located. So remember, what I needed from here was what is cosine, which I already have it. So I didn't really actually need to draw this, but we did because we already knew what cosine theta was, and all of the formulas use cosine theta for half angle. But we did need to know what quadrant we were in. That is important. So for the half angle part, since we are in quad 3, remember this is to figure out if we're going to be choosing a plus or a minus for our formula. Oops, and I dropped that off on that last one. Sorry about that. I dropped off my negative sign. So the final answer on that last one was negative 3 square root of 13 over 13. I lost the negative. But the half angle's location, so this is, remember, from 180 to 270. So half of that would be 90 degrees to 135, which is again in quad 2. The reason that matters is in quad 2, tangent is going to be positive. So we're going to choose the positive case here. Oh, sorry, no, I just said that completely wrong. I looked in quad 3. Too much brain. In quad 2, tangent is negative. Because we'd be up here with negative x's and positive y's. Okay, so the formula for tan of a half angle is the square root of 1 minus cosine of theta over 1 plus cosine of theta. And we said we are choosing a negative because of the quadrant location for the half angle. And now we're ready to plug in. So this is just negative square root of 1 minus negative 15 over 17 over 1 plus negative 15 over 17. And that's all under this big radical. I would multiply everything on top and bottom by 17. So that's 17 plus 15 on top. And we can break this into two radicals now. That would be 17 minus 15 on bottom. So that is negative square root of 32 over square root of 2. You could reduce here by pulling out a square root of 2. So that would be just negative square root of 16. So that's just going to be negative 4. Okay, and then the last one for this video is number 26, and then I'll do the rest on part 3. So let me give myself some more room for 26. Sorry, this thing's a little slow. This time we're given cotangent, so we are going to have to find our cosine since they didn't give it to me. And they told us that secant or cosine is a negative family this time. So less than 0. Okay, so it's going to work. Probably pushed spacebar too many times. Yes, I did. All right, so for this one, we are looking at tangent family being positive and cosine family being negative. So when we look at what quadrant we're in, tan is positive, cosine is negative. That is in quad 3. All science teachers crazy. And cotangent is that, so I'm going to flip it to make tangent. So that's 7 over 24. So that's 7, that's 24, and we've done this one before, but my head is very tired. That is 6, yeah, that's 25. And then remember, x and y are both negative here because you're in quad 3. So the reason we needed this picture, remember, was for the theta location so that we could find cosine of theta. So that is negative 24 over 25, okay? And then for the half angle location, this is again, the original was between 180 and 270. So the half angle is going to be between 90 and 135 if you take half of both of those quadrant boundaries. So then this guy right here is quad 2. And in quad 2, sine is positive. So that's why we're going to go with the positive on our formula, because sine is what we're doing the half angle formula for. So sine of theta divided by 2 is going to be positive because of my choice right here. That's why I'm choosing that plus or minus. And then square root of 1 minus cosine theta over 2. Okay, so this is the square root, positive square root of 1 minus negative 24 over 25 all over 2. That's going to be plus plus. If we multiply everything by 25, that would be 25 plus 24 on top over 50 on the bottom. And 25 plus 24 is 49. So that is going to be a nice square root on top. So that's 7 over 50. Also has a perfect square that goes into it, 25. So that'd be 5 on the square root of 2. And then I would multiply by square root of 2 on top and bottom to rationalize. So my final answer for the sine of theta over 2 is 7 square root of 2, and this would be square root of 4, so that's 2, so 5 times 2 is 10. So there's that one. And that is the end of this part of the video, so that's the end of part 2.